Hi class, welcome to lecture 2.3, time value of money. So now we're going to continue the lecture that we had from 2.2. This is also on the time value of money, but we're moving to a slightly more complex issue of dealing with payments. Payments are even cash flows or even uneven cash flows where we would have to use some different buttons in your calculator. Once again, a lot of this information is taken out of chapter 5 in the book. Obviously, this would be the latter half of that chapter. And I've just once again reminded you with the same practice problems. They're not graded, but they're there for you to practice, and you can do more if you want a challenge. So there are really going to be four different components for this lecture, and they have to do with uneven cash flows, even cash flows, different types of interest rates, and different types of loans. So some key concepts and skills that you want to focus in on. You want to be able to compute both the future value and the present value for multiple cash flows. You're going to want to be able to find both the payments and the interest rate for various types of loans. And you also want to understand how loans are amortized and what that really means, and also how interest rates are quoted. So here are the four different areas for this lecture. We're going to talk about uneven cash flows or multiple cash flows. We're going to then talk about even cash flows with annuities and perpetuities. We're going to talk about EAR versus APR when we're talking about compounding. And then we're also going to talk about different types of loans such as, amortization. Once again, just like in lecture 2.2, there's really three ways about going about these problems. You can use the formulas, you could use Excel, or you can use your BA2+. In this lecture, I'm going to teach you using BA2 Plus primarily because that's the easiest way. That's the way you'll probably do it on the exam. That's the way I teach it. And also, that's the way I present answers on your test guide. So let's just start right out with an example for multiple cash flows. You think you will be able to deposit $4,000 at the end of each of the next 3 years in a bank account paying 8% interest. You currently have $7,000 in the account. How much will you have in 3 years? How much will you have in 4 years? So, right now we know that we have $4,000 in year zero. $7,000 in year zero, and then we're going to add $4,000 each of the next 3 years. What we could do is do a simple time value money formula like we used in lecture 2.2 for each of the years and then add them up. Let's see what that would look like. So, looking from a formula perspective, you could find the values for each specific year and then move that value, however many years down the road until you're at the current future value, right? So in year zero, you're going to start with $7,000. You're going to want to push that 3 years down the road at an 8% interest rate. So you take 7,000, multiply it by 1.08 raised to the third power. You get $8,817.98. In year 1 and 2, you're going to get $4,000, so you're going to push those 2 years ahead and 1 year into the future. And then in year 3, you're going to have $4,000, and you're already in year 3 when you're doing this last calculation, so you don't have to do anything with that $4,000. And then you just sum all those together, and when you sum all of them together, you have $21,803.58. To find the value year 4, you can then just multiply all of that by 1.08, and that would give you $23,547.87. Now, as interesting as that is, you could have skipped this very last step if you would have just added one more number to each one of the steps, meaning in year 0 you could have raised to the 4th power, year 1 to the 3rd power, year 2 to the 2nd power, and then year 3 to the 1st power, and then sum them up and been done. So either way you want to do it, but that's how you would use the formulas. So let's take a look at another example. If you deposit $100 in 1 year, $200 in 2 years, and $300 in 3 years, how much will you have in 3 years at 7% interest? How much in 5 years if you don't add additional amounts? Okay, so we can do this in a very similar way as we did last time with the formulas, but let's add a little bit of a twist. This time let's use formulas and a timeline. So what you'll see right here is a timeline that shows how you would use each formula, and then you would sum them up, and in the end you would have that $628.49. Now, if you wanted to try to figure out the total interest, you could subtract the $600 you received over time from the $628.49, and you'll see you made $28.49 of interest over that period. Now, that first box is the answer to the first question of what you'd have in year 3. If you push that 2 years into the future by multiplying it by 1.07 raised to the second power, then you get $719.56. So that would tell you how to do or find the value of that account at year 5. Now you can also do this in Excel, and I've provided you just a little bit of information on how you would go ahead and do that in Excel, and you can obviously click on the little Excel button too, and hopefully that will give you some idea of how you would do this in Excel. Moving on, let's take a look at another example. Now in this third example using multiple cash flows, suppose you invest $500 in a mutual fund today, and then you also invest $600 in a year. If the fund pays 9% interest annually, how much will you have in 2 years? Okay, this is pretty easy. You can use this formula below. You're simply going to push the $500 2 years and the $600 just 1 year. So if you notice there's no 1 by that where it says 600 times 1.09 raised to the 1, there is no 1 there because that 1 is simply understood. But you would sum those together and you'd have $1,248.05. Now, a more interesting question might be to ask, how much will you have in 5 years if you make no further deposits? You actually have two options here. The first way is to simply go back and take the $500 and push it 5 years to the future, and the $600 and push it 4 years to the future and add them up. The second way is to use the values you've already calculated and to push that value 3 years into the future. Either way, you should get $1,616.26. Okay, let's look at another example, and by this time you should be getting the hang of it. So suppose you plan to deposit $100 into an account in 1 year and $300 into an account 3 years. How much will you be expecting in your account in 5 years if the interest rate is 8%? Well, you simply need to just know how long you're expecting to push these values into the future. So the $100 gets pushed 4 years, the $300 gets pushed 2 years. You're going to sum those together and get $485.97. And if the formulas were slightly confusing, throw them in a timeline, right? So here you'll see the timeline where you're pushing the $100 4 years in the future and the $300 2 years in the future, and getting or arriving at the exact same answer. So if you need the timelines, draw the timelines. The main point is you want to get the right answer. And here in a minute, I'm going to show you with some test guide problems how you'd go about doing these in your calculator. Let's move on to something slightly more complicated. Let's look at figuring out the present value of multiple cash flows. Okay. All right. Let's assume you're offered an investment that's going to pay the following multiple cash flows: $200 in year 1, $400 after that, $600 after that, and $800 at the end of the 4th year. Now you're going to get 12% interest, or let's assume you can earn 12% on similar investments. What is the most you should pay for this one? So when they ask what is the most you should pay, you're really trying to figure out what is the value of this investment, the present value of this investment. So we have to find the present value of multiple cash flow. Now looking at this from a formula perspective, you can find the value of each one of the annual cash flows. But when I say value, in this, instead of going after the future value, we're now going after the present value. So you're going to be discounting back each one of these cash flows, and that's why you will see a division sign there, because we are calculating the present value with the formulas now, not the future value. So if you're confused, go back and look at what the present value formula looks like in lecture 2.2, but you're going to discount $200 back 1 year, $400 back 2 years, $600 back 3 years, $800 back 4 years. You're going to get each of those values. They're obviously going to be less than the original amounts, right? So like $178.57 is less than $200, $318.88 is less than $400, and so on. But you'll sum all of those amounts And so the total value, or the present value, the current value for these multiple cash flows is $1,432.93. Now, if that seems somewhat confusing, take a look at the timeline, right? Remember, a timeline can be your friend. So here you're going to actually see the arrows going in the opposite direction because now we are discounting back in time, right? So we're, instead of calling this 12% an interest rate, it's probably a little bit more appropriate to call it the discount rate in this point because we're going to discount back the $200 1 year. We're going to discount back the $400 2 years, the $600 3 years, and the $800 4 years, and we're going to still arrive at that exact same number of $1,432.93. Now, if you prefer to do everything using the formulas, that's fine. However, you can do most of these problems much faster using your TIBA2 Plus. Okay, if you look on your calculator, I'd like to talk to you about some new buttons that you want to become familiar with. The second button, which is going to be on the second row from the top, the first button. If you hit that button, it allows you to use the other settings within each button. In this case, if you will hit, for example, the last button on the first column of buttons, right? So on the first button on the very last row, that CE/C button, that's the clear button. That allows you to clear anything. Well, if you hit the second button and hit the button right beside the second button, which is the cash flows button, it should say cash flow 0 equals 0. Now, if you will hit that second button again and go back and hit that clear button, you'll see above it says CLR work. You just now cleared out all of your work within your cash flows button. And that's important to do so that each cash flow problem you do doesn't have any hangover information that causes you to miss a problem. An example would be if you did a problem with 7 cash flows and then the next time you just went over the top of it for a problem that only had 3 cash flows, well, those last 4 cash flows are probably still in there and they're going to definitely mess up your answer. So just make sure you remember to hit second clear once you get into the cash flow buttons each time. Okay? Now let's talk a quick second about the actual cash flows. You know, if you don't have any money up front that we're talking about for an investment idea or any kind of savings project, then your cash flow 0 is just going to be 0. In that case, you can just hit the down arrow to go to cash flow 1, which would be C01. Now, when you're putting in your cash flows, what you want to remember, if it's cash coming in, that's positive, and if it's cash going out, it's negative. So you need to make sure you get your sign convention correct. Now, to put something in for, like, say, cash flow 1, just to play around, I'm going to put in $500. To do that, now I have to hit enter to lock that in. If you don't do that, then you haven't really locked anything in. So as you can see on this slide gives you more information about exactly how to put the information in for all of your cash flow problems. So once again, if I wanted to start all over, I could hit second cash flows. I'm in my cash flows. I'm going to hit second clear to clear everything out. And my cash flow 0 says 0. Let's assume that it is 0. I'm going to hit the down arrow, cash flow 1. Now to put a number in, I said 500 before, so let's do that again. Hit 500, enter, and that now it's locked in. If you just hit the down arrow, you wouldn't have locked it in. But now hit the down arrow and you'll come to F01. F stands for frequency. How many times in a row would you like that $500? If it only happens once, you can leave it alone. The default setting is 1. However, if you do want to change that to, let's say you get $500 15 years in a row. So I change that to 15, and then I'm going to hit enter to lock that in. If you hit the down arrow again, cash flow 2 should pop up, and so you could go through all of these. In cash flow 2, let's put in $65. Now, this is not year 2 because my frequency is 15, so this is actually year 16. And I'm going to do $65 and hit the down arrow. And I'm going to go back up with the up arrow. My cash flow 2 says 0. Why? Because I forgot to hit enter after I put in that 65. So 65, enter. I'm going to down, and now I have another frequency. Maybe I get this for only 10 years. So 10, enter, and so on and so forth. So that's how you would go about putting information into your cash flows. Now, once you have all the cash flows entered, you can hit the button right beside the cash flow button, which is the MPV button, and it says MPV right on top. So you hit that button and an I will pop up. It'll say I equals 0. Now you want to change that to something. So in this case, we'll change it to 5 for 5%. So hit 5 and then enter. Now notice that I just put in 5. I didn't put in 0.5. So the calculator lets you put it in as a percentage, not a decimal, which is, just done simply for convenience. So if you're using a formula, you always want to put it, an interest rate in as a decimal. But if you're going to put it into your TI BA2 Plus buttons, you're going to put in those interest rates as a percentage. So after you hit enter to lock in your 5% interest rate, you're going to want to hit the down arrow, okay, and then all you have to do after that, it should say MPV equals 0, and you'll want to hit the compute button, which is obviously that top button on the left. And in this case, I got $5,431.26. So if you got a number like that, then that should tell you that you're starting to understand how to work the cash flows. How about the problem that we were doing earlier? Well, how would we put it in? Well, look in this slide, you can see exactly how to do it. You would put all the cash flows in a very similar manner that we did last time. So the first thing you want to do is hit second, or you just hit your cash flows really, and then hit second clear to clear all your cash flows out of the cash flow button. And then you're going to put each of these in. So cash flow 0 is already 0. You can put 0 in there, but it's not necessary. And then you hit the down arrow to cash flow 1. You're going to do 200, enter, down arrow. Now because the frequencies aren't changing, these are from 1 year to the next, you can just skip right over frequency 1, its default is 1, and move on by hitting the down arrow to cash flow 2, put in 400, hit enter, skip over the frequency, go to cash flow 3, hit 600, hit enter, go to cash flow 4 and hit 800, enter. Now you're going to hit MPV button. Your I in this case is going to be 12, so you hit 12, enter, down arrow, MPV should pop up, and you're going to hit compute, and you should get $1,432.93, just like it shows right here on the screen. Alright, so this should give you a lot of confidence that you now know how to do uneven cash flows or multiple cash flows. And I think most of you will also agree with me that this is a faster and easier way than using the actual formulas. So let's take a quick quiz real quick and see, whether or not your skills are up to par. Suppose you're looking at the following possible cash flows. Year 1, cash flow is $100. Years 2 and 3, it's $200, and years 4 and 5, it's $300. The required discount rate is 7%, so that would obviously be your I button. What is the value of the cash flows at year 5? What is the value of the cash flows today? Alright, so this can be somewhat tricky depending on how you want to go about doing this. Just to throw things, or a twist into this lecture, maybe we'll start with something different. Let's take a look at how would we do this in Excel first. So this slide shows you how you'd set everything up in Excel, and also has the link to the Excel spreadsheet. So if you want to do that, there you go. Or you could also use, the timeline and formula solution, right? So this timeline solution here shows you when the arrows are going forward what it would be like in the future value in year 5, or with the arrows going backwards what the present value is, and obviously the present value is going to be much smaller than the future value. Now how would you go about doing this in the calculator? Well, obviously to find the present value you can just use put all of these values in your cash flows like we talked about before in the cash flows button and solve for MPV, and that will give you the present value. The future value is slightly trickier depending on which type of calculator you have. You could a button under your MPV button, meaning that if you hit the down arrow after solving for MPV, that you could also get net future value. That's a professional version of the BA2 Plus. Most people don't have that. Most people have a regular BA2 Plus. So that would just mean you take your present value, do one small time value money problem, and push that 5 years into the future, and then you have your answer, right? So you could make your net present value your present value. Your interest rate would also be whatever you used for I. So in this case, that would be 7%. Your net present value becomes your present value. Your payment is 0, and you would solve for future value, assuming that, like I said, you put everything at all the other 4 buttons in. N equal to 5, I equal to 7%, PV equal to NPV, payment equal to 0, compute for future value. Now you have your net future value at the end of year 5. That sounds a little bit confusing, so why don't we look at some problems from the test guide to make sure that you guys are fully prepared for the exam. Let's start with problem number 19. If the appropriate discount rate for the following cash flows is 12.5% per year, what is the present value of the cash flows? So you've got all these cash flows that are neatly typed out and then all of my handwriting gibberish. And step 1 will be to enter all of these cash flows, right? So the first thing you'd want to do is hit cash flow button, and you're going to hit second clear to clear everything out, and then cash flow 0 is obviously 0, so you go past that. Then you're going to put in each one of these cash flows. So like the first one would be 22,500. Hit enter, hit your down arrow. They're changing from one year to the next, so we're not really messing with the frequencies much. And so you go to cash flow 2, put 27,940 in, hit enter. You jump right over the frequency again to cash flow 3, 37,100. Go to the last cash flow, which is 15,800, and lock all those in by hitting enter. Then you're going to hit the NPV button. I here in this case is going to be the 12.5%, so 12.5 enter, down arrow, NPV, you hit compute. Now, that should give you the $77,996.43. Now, this problem didn't ask you to figure out what that value would be like in the future, so let's take a look at one of those problems. Okay, looking at number 17 on your test guide, if today is year 0, what is the future value of the following cash flows 10 years from now? So we're now looking at the net future value in year 10. Assume an interest rate of 8.9% per year. So once again, you'll do it very similar to what you did last time. However, if you notice, you're not going years 1, 2, 3, 4. This time you're going years 2, 3, and 6. So there's some years there where nothing happens. Well, you don't want to confuse the calculator, so make sure that for those other years you put 0. So first thing I'm going to do here is hit cash flow button, second clear everything out. Cash flow 0 is going to be 0. Go to cash flow 1. Now it won't let you go past cash flow 1 and frequency 1 unless you put something in. So in cash flow 1 you actually have to hit 0, enter. Then you'll see cash flow 2 will pop up. You'll put in 10,500, enter, and you go to cash flow 3 and hit 17,940, enter. You get to cash flow 4, you can put in 0, enter, and now you can do for your frequency 2 if you'd like, because there's 2 years in a row, years 4 and 5. I'm going to do that. Hit enter. And now my cash flow 5 is year 6. If you don't like that and you wanted your cash flow 6 to be year 6, then you could have kept frequencies at 1 for both of those years, and then you would have been able to have cash flow 6 at 7,100. But I changed my frequencies just to make my life a little bit quicker, and I'm going to put cash flow 5 equal to 7,100. I'm going to hit enter, and my frequency here will be 1. Okay, so now that I got everything locked in, I'm going to hit NPV. Now my I button here is going to be 8.9, so 8.9, enter. Hit the down arrow, hit compute, and you should have an NPV of $27,001.92. Now, that'll probably be an answer choice on an exam. However, in this case, that would be the wrong answer choice, because we're not looking for the net present value. We're looking for the net future value. Now, some of you have the option to hit the down arrow one more time if you got one of the big fancy professional calculators, and then NFV would pop up for net future value, and you could hit compute. Be careful in this case, because you're going to actually end up getting the wrong answer if you. And the reason being is that you've only put in 6 years of cash flows. So if you actually wanted to use that net future value on your calculator, you need to go back into your cash flow button and put in 0 for cash flow 6 and add that for for enough years to get you all the way to year 10. For the rest of us, don't worry about anything I just said. You've got your MPV. Your MPV says $27,001.92, and now we're going to just manually move that into year 10 by using our time value money buttons. So the first thing I would do is I would hit clear, that button at the very bottom, and the only reason I hit clear is because it makes the words MPV go away. And then I'm going to hit the negative sign, okay, to load that in to my PV. So my PV here is negative. Now it doesn't matter, you could have left that alone and then your future value would have been negative, but I'm going to go ahead and put it in as negative, and I'm going to do this for 10 years, so I'm going to put in 10 for N. My interest rate is the same thing I used for I, so that's going to be 8.9. We're not dealing with payments at the moment, for at least just for this problem, because we're just pushing this together at this present value for 10 years. So I'm going to put 0 for payment, and then I'm going to hit compute FV, and you should get $63,339.34. And I also added some green arrows into this slide to kind of help you understand my thinking process during this problem, and where you can, take some information and plug it into others to help you use the BA2 Plus TI buttons for calculating uneven cash flows. So that's how you do cash flows, and I think understanding and using the cash flow button is one of the harder things on this exam, but that's a very valuable tool for you for the rest of your life. And I think a lot of you can now understand that you could use this to help you figure out all sorts of math problems that might come up in your life as far as saving for the future, or considering out how loans work. So now we're going to move on and look at some real world concepts with this. And there's not a lot of conceptual material in this lecture, but the next slide actually presents a big chunk of that. Now, what do the perpetuities and annuities look like from a formula standpoint? Well, the perpetuity formula, which is number 6 formula on your test guide, super easy. Okay, it's the present value equals a payment over R, or some cash flow over R. So using the example I said before, if you were getting $5 million a year from an annuity and you divided it by let's say the 5% interest rate, then that would give you a $100 million perpetuity, right? So whatever that cash flow is, you want to divide it by the interest rate. Now that interest rate, or that required rate, or whatever that rate may be that you want to call it, you want to make sure that we're putting that in as a decimal here, because we're using a formula, right? So don't put it in as a percentage, you'll be a couple zeros off. Now with annuities, to figure out the present value or the future value, you'll see payment there. Sometimes you'll see that written with a C instead of the words PMT, right, for cash flow, or maybe CF for cash flow. And then you'll see that the formulas here are getting slightly more complicated. Luckily, you've got your calculators, so that once again, a lot of folks won't want to use these formulas at this point, but I wanted to show you them so that you could understand mathematically how to figure out them if you wanted to use the formulas. So how would we use our BA2 Plus calculator? Well, now we finally get to use the payment button, right? So if you look on the time value money line, we've been putting in 0 for payment. It's time that we actually start putting in a number there, right? Now, once you start putting numbers in for the payments, the sign convention rules become far more important. So you want to make sure that if money's going into the system, that is negative, and money coming out is positive. And this is extremely true if you've got actual numbers, above 0 numbers for present value, payment, and future value. For example, bonds. When we get into bonds, you'll see why this would be really, really important. Now this slide also talks to you a little bit about switching, from beginning to ending payments for ordinary annuities and annuity dues. Now, once again, this slide might explain it, but like I said, I'm going to try my best not to make you have to do this too much. Just know that an annuity due is done with, your settings at BGN, or beginning, and ordinary annuity, which are most problems, is going to be set at the end. Now you can also do all of this in Excel. Once again, that's up to you if you want to do it. I've given you some information here. If you find it useful, that's great. Okay, there's also some important points to remember. The interest rate and the time period must match. In other words, if we're going to use 5 years then and n equal to 5, then you have to use a annual interest rate for your I divided by y button. If you were to want to do that in months, so then n would be 5 times 12, which is 60, so your n would be 60. That I divided by y would have to be a monthly interest rate. And then, make sure you have your sign convention correctly. However you want to say it. I say if I'm putting cash in the system, it's negative, and it's coming out, it's positive. Here, this slide is saying the same thing, but it looks slightly different. It's saying cash inflows are positive and cash outflows are negative. But remember, that's all about perspective. So in this case, cash inflows to you, which would be coming out of the system, are going to be positive. That's money into your pocket. Cash outflows, that's money coming out of your pocket into the system, are going to be negative. So make sure you understand the wording there, but you're going to make sure you just keep everything straight. So if money's going into the system and out of your pocket, that's negative. If money's coming into your pocket and out of the system, that's positive, right? So once again, here's a slide that has all the formulas on it, and you just can use this as a reference table. Let's take a look at the last one there, perpetuity equation. Remember, that's just payment over R or C over R. And let's try an example. So remember, the perpetuity formula is PV equals payment over R or C over R. And in this case, remember these are dashes here on this slide. They're not necessarily negative signs. So if 40 equals 1 over R, then R would equal 0.025 or 2.5% per quarter. So you can use this equation to solve for R, or you can also figure out it for the payment. If you had $100 present value and 2.5% per rate, then you could figure out that you're paying $2.50 per quarter as a dividend. Let me show you what one of these problems would look like on the test guide. Specifically, let's look at number 23. A recent alumnus of your university gifted money to the school to fund annual scholarships for needy students. Remember, we talked about how you can set up endowments using a perpetuity. The school expects to earn an average rate of return of 5.5%. So there's your R. Make sure you put this as a decimal since we're using an equation, not as a percentage in the equation. So, and then distribute $50,000 annually. So there's your C, or your payment, in the form of scholarships. So what was the amount of the gift? All you have to do is take the $50,000 and put it over 0.055 for 5.5%, and you're going to get a pretty nice little endowment here of $909,000, or $909,090.91. Okay, so almost $1 million endowment that was set up here as a perpetuity. So that's how perpetuities work, and there's a lot of real-world examples. Let's also take a look at some of these ordinary annuities that we talked about earlier as well. Okay, so to do a regular annuity problem like number 18, we're going to end up using the payment button on our calculator. So let's take a look at it. You want to borrow $56,000 from your local bank to buy a new sailboat. You can afford to make monthly payments of $950, so there's your payment, but no more. Assuming monthly compounding, what is the highest rate you can afford on a 120 month APR loan? Okay, now APR stands for annual periodic rate loan, and we'll get more into that in just a second, but for right now, let's figure out what we're going to put in for our buttons. Okay, now what is a loan? If you think about a loan, it's a money up front, so that's money that's coming out of the system, but it's into your pocket, so that's positive. Eventually, you're going to pay that loan off, so the future value is going to be zero, and that's important because they're not going to probably tell you that in the problem. And then a payment is something you're going to be handing over in this situation, so that's going to be negative. So let's start and see. We have 120 months, so what I'm going to do is I'm going to put in 120 for my N. Now, they tell you that this is a 120-month loan. What they're basically telling you is that there's compounding going on a monthly basis. So you also have to figure out what the monthly interest rate is for I. If you look in this situation, we're solving for I. So keep that in mind, and I'll tell you why we should keep that in mind when we get to the answer. Let's go ahead and put in the present value. Present value is going to be $56,000 because that's what the bank gave us. Okay, notice I didn't make that negative. I'm going to be paying over $950. I'm going to hit the negative sign, make that negative, and put it in for payment. I'm going to make future value equal to 0. And then I'm going to hit compute for I divided by y. Now I'm going to get 1.36% when I do I divided by y. I have just solved for the monthly interest rate because I used monthly periods. So if I want to have the annual interest rate, which is the annual periodic rate, then I will need to multiply that by 12. Okay, because there's 12 months in a year, and I get 16.34%. So 16.34% is my annual periodic rate. Make sure you solve for that annual interest rate. That monthly interest rate would probably be one of the wrong answer choices on your exam. All right, so let's take a look at one more of these annuity problems. Number 24, Used Motors will sell you a $15,000 car for $580 a month for 30 months. So what is the interest rate here, or is this a good deal, or whatnot? Okay, so we need to figure out, we're going to be doing this in months, okay? So N is going to be 30 for 30 months. I is going to be what we're solving for, but we're going to end up getting that in a monthly rate that we have to multiply by 12. The present value is going to be positive in this case because you're actually getting a loan through this used motors company. So it's almost like they're the bank, or they're giving you some kind of in-house financing. You're going to be paying over $580, and your future value is going to be 0. So this problem works exactly like the last problem. You solve for I, you're going to get 0.9856. That's a monthly interest rate multiplied by 12, and you get the 11.83% interest rate. That's a pretty high interest rate on a loan. So obviously, by taking this class, you now know that that would not be the best deal. Make sure you remember that if it's, if the problem doesn't specify it, that the default is always to solve for the annual periodic rate, not the monthly interest rate. Okay? All right, now we're going to switch gears and talk a lot more about interest rates. Okay? All right, let's talk a little bit about interest rates. Now, there's the effective annual rate. Okay, this is pretty much the exact amount of that you're going to get charged each year from an interest perspective, or the exact amount you're going to make each year from an interest perspective if there is compounding going on within the year, meaning on a monthly basis or a quarterly basis or a daily basis. If it's the compounding is on an annual basis, then the effective annual rate will be the same thing as the APR, which is the annual percentage rate or nominal. Now, the APR is what you get quoted on like credit cards and bank loans and things of that nature, but it's not exactly the amount of interest that's being charged. It's more of the annual rate that's quoted by law. Now, obviously, I think it would be more effective, efficient, and ethical for the banks to quote the EAR, but obviously they like that APR because it's lower. So when you're thinking about EAR and APR, there's a couple things to remember. You always need to make sure that the interest rate and the time period match. Okay, so remember, we're talking about your N button and your I divided by Y button here. If you're going to be working with months, they both need to be in months. If you're going to be working with years, they both need to be in years. Quarters, they both need to be in quarters, and so on and so forth. Now let's look at the formulas. Okay, you have the effective annual rate equals 1 plus the annual periodic rate over M raised to M minus 1. And what is M? M is the number of compounds per year. So if you're dealing with months, M would be 12. Quarters, M is 4. Daily, M would be 365. If it was semi-annually, then M would be 2, right? So there's a couple different numbers that you could have there for M, but it's the number of compounds per year. You could also rearrange this and solve for APR using the other equation too. We'll probably want to do this in your calculator because it's pretty easy. All you have to do is hit the second button and then hit 2, and what you've really done is gone into that I conversion or ICONV, that stands for interest conversion section of your calculator, and what you'll see pop up right away is NOM, N-O-M. NOM stands for nominal, and that's the same thing as APR, so you put in a value there. If you hit the down arrow, you'd say EFF, that stands for effective, so that's the same thing as EAR. And then you see C divided by Y, which is compounding per year, so that's the same thing as the M in the equation. If you will put in values for any two of these and then use your, obviously hit enter and then use your buttons to go back to the one that you want and hit compute, it will give you the value for that. So that's obviously a very easy way to get the information. Now, if you're looking for the effective annual rate or the APR, or what we're calling nominal here in Excel, I've also given you these functions, and just in case you wanted to add those to your toolbox. So let's look at some decisions you might have to make. Which savings account should you choose? A 5.25% savings account that has daily compounding, or a 5.3% savings account with semi-annual compounding? So the truth here, if you're trying to find some way to compare these, is to find the effective annual rate for each one of these accounts, and those are the numbers that you can effectively compare to each other. So we're looking for the effective annual rate here. So if you will put these values into your calculator, for example, hit second 2 and go to NOM, and let's put in 5.25, hit enter, down arrow, go past EFF, go to C divided by Y, so you're going to hit the down arrow twice, and let's change that to 365, hit enter, and then go back using the up arrow and hit compute for EFF, and you should get 5.39. Okay, and the same thing would be true for the second account as well. So by comparing these, you will see that the first account actually pays you slightly more than the second account, even though its periodic rate was actually a little bit lower. And by periodic rate, I mean annual periodic rate in this case, because its daily periodic rate would be much, much, much lower. So you can't go by APR. You have to go by EAR if you're going to compare different types of saving vehicles over different types of compounding periods. Continuing with APRs, what is the APR if the monthly rate is 5%? Okay, in this case, you can simply multiply that 5% monthly interest rate by 12 to get the APR. And if you were using a quarterly rate, then you would multiply by 4. The next bullet point says semi-annual rate, so you multiply by 2. Then you get to the question, what is the monthly rate if the APR is 12% with monthly compounding? Well, now you're dividing instead of multiplying, so 12% divided by 12 is just 1%. So that 1% would be your monthly interest rate. So if you're going to the periodic rate, you're going to divide. If you're going to the annual periodic rate, you're probably going to multiply. If you're looking for the annual rate with an APR, then the annual periodic rate is the annual periodic rate, right? So in that case, you wouldn't have to do anything. It's also important to remember that this APR, it comes from the periodic rate. So you can't use this APR for another situation, such as taking the same APR and dividing it by 2 to get the semi-annual rate. You would need to figure out the APR using the semi-annual periodic rate first. So just be careful of that. I don't think I have any problems that are going to trick you in that way, but that is something to make sure you conceptually understand. All right, so here are some questions from the quick quiz. What is the definition of an APR? What is the effective annual rate? Which rate should you choose or should you use to compare alternative investments or loans? And which rate do you need to use in the time value of money calculations? So remember the definition of the annual periodic rate. That's the rate that you have to quote by law, at least credit card companies and banks. And it's just going to take whatever your periodic rate is and multiply it by M, or the number of compounding per year, to get that annual periodic rate. The effective annual rate, though, is going to give you the proper percentage rate of interest you're being charged for a year based on all of the compounding that may be going on within that year, whether it's on a monthly basis or a daily basis or whatnot. So which one should you use to compare alternative investments or loans? You really should use the EAR, but a lot of people will use the APR because that's what's quoted at the top of on any kind of loan applications. Now, a lot of loans are, the standard is monthly, so if you're comparing apples to apples, that's not too bad. you don't know maybe the exact amount of interest you're being charged, but at least you're comparing, the same type of APRs, which are all based on, monthly periodic rates. Regardless, the effective annual rate would still be the better choice for making comparisons. And then which rate do you need to use in the time value of money calculations? Well, the reason here that APRs might work out a little bit better is just, they're easier to divide or multiply by, and to plug in those periodic rates that you need. So if you're doing a problem, for example, in months, if you know what the APR is, you could divide that simply by 12 and plug that into your I divided by Y button. So in that case, it's probably a little bit easier to use the APR information in your time value of money calculations. But if you want to know which one was more precise or the exact answer for the amount of interest you got per year, that would be your effective annual rate. For example, let's take a look at number 20 on your test guide. You want to buy a new sports coupe for $94,600, and the finance office at the dealership has quoted you an 8.1% APR loan. Told you, they always tell you an APR, not EAR, for 60 months to buy the car. What will your monthly payments be? So that we're going to calculate all this in months. And what is the effective annual rate on this loan? So this is like a two-step problem, or two different problems in one. First, let's find out the monthly payment. Okay, so in this case, we're going to solve for payment, which is, we actually haven't done that yet. So put in for your N, put in 60 for months. For I, you're going to take that 8.1 divided by 12, and you're going to enter 0.675 for I divided by Y. For PV, you got they're giving you $94,600 in a loan, so that's why it's positive. For PV, you're going to pay that loan off, so it's zero for future value, and you're going to hit compute payment. And you should get negative $1,922.68. That would be a huge car payment, by the way. That's much closer to a big fat mortgage payment on a house than it is a payment for a car. But if that's, want to live out of that car, then good for you. And then how would we go about figuring out what the EAR is on that loan? Well, you could hit your second to button, which gets into interest conversion. You can set nominal, or NOM, which is nothing more than the annual periodic rate, equal to 8.1. Hit the down arrow twice, go to compounding per year and make that equal to 12. Hit enter, and then go back up to your EAR and hit compute, or the EFF really, but that's effective for effective annual rate, and you'll get an EAR of 8.4076%. So although the dealership will tell you that they're charging you 8.1% in interest per year, they're effectively charging you 8.4%. And some of you may say that's pretty close, so what's the big deal? Well, first off, I'd rather know the exact right answer, but for a lot of major corporations, we're adding a lot more zeros too. So if you're looking at a $1 million loan or a $1 billion loan, you start adding zeros, and you're talking about quite a big difference in the amount of interest you're paying. And so try to multiply those numbers times $100 billion, and then see what the difference would be. It's not chump change, we'll put it that way. Let's take a look at another problem. This one shows you which bank is offering you a better deal, similar to the example that we worked just a couple moments ago. First Bank offers personal loans at 8.6% compounded monthly. Second Bank offers similar loans at 8.4% compounded semi-annually. Which one of the following statements is correct concerning these loans? And so this is where you would have a bunch of answer choices, but really what they're wanting to know is which bank gives you the better deal. That's going to be obviously from an effective annual rate perspective. So you plug in using your second to feature on your calculator. You're going to plug in the nominal rates. You're going to change the compounding per year to 12 in step 1 and to 2 in step 2. And you're going to solve for the effective annual rates. And one of the things that you will notice is that in this case, the bank that had the higher APR also has the effective annual rate, whereas the bank, so 8.6 compounded monthly is going to be 8.94% or 8.95%, whereas 8.4 compounded semi-annually is going to be 8.6%. Okay, so you're definitely getting a better deal from First. Well, let me rephrase that. First Bank is better is getting a better deal if you go with them because they're getting a higher interest rate from you. You want the lower interest rate. Now let's look at deal is one more easy problem. What is the effective annual rate of 12.4% compounded quarterly? Okay, I just wanted to throw this one in there to show you that it doesn't, have to be just monthly or semi-annually. We're going to try something different. So obviously nominal is going to be the APR, so you just put in 12.8, hit enter, down arrow twice. When you get to compounding per year, how many times per year is quarterly? Well, there are 4 quarters in a year, so that would be 4, hit enter, up arrow compute, and you get 13.4276. So that's your answer right there. So the APR was 12.8%, but the EAR was 13.43%. So that does it for the math portion of this lecture, and we've just got 4 more slides to go over a couple of unique terms that I would like you to know as well. Okay, so we're going to talk about 2 different types of loans, a discount loan and amortization or amortized loans. Now, if you think about a pure discount loan, you're thinking about a loan that's not going to really pay you interest payments. It's just going to pay you some principal amount down the road. The slide obviously here indicates that treasury bills are a great example. There's also bonds out there called zero coupon bonds, which when we get into the bond exam, that we'll definitely talk more about them. But let's look at an example, and just that should probably help you understand pure discount loans. If a T-bill promises to repay $10,000 in 12 months or a year, and the market interest rate is 7%, how much will the T-bill sell for in the market? Well, as you can imagine, they don't call them discount loans for nothing. You're going to sell this for less than its face value of $10,000. So n's going to be equal to either 12 or 1. Well, in this case, we're going to assume that we're doing everything just on an annual basis. So in this case, n will be 1. The future value would be $10,000, which is what you expect to get. I is going to be 7%. Payment is 0 because that's why it's a pure discount loan. It's not making any payments, and you'd find out that you would pay $9,345.79 for this bill in the market. That's what it's worth. Now you could have also done this on using n equal to 12 and I equal to 7 divided by 12 if you thought that interest was accruing on a monthly basis. But in this case, it's an annual basis. You would work it this way. We can also look at an amortized loan with fixed payment. In this case, each payment is going to cover the interest expense plus reduce the principal, and this is very much like a mortgage. I have a mortgage, and a lot of people have mortgages if they're trying to buy homes because they don't have the money to pay for it outright. Maybe they put 20% down, and then they're going to have an amortized loan where they're going to pay a mortgage payment, but most of that's going to go towards interest up front, but slowly over time you're going to cut into that principal and eventually pay off the whole principal. So let's look at an example. Consider a 4-year loan with annual payments. The interest rate is 8% and the principal amount is $5,000. What's the annual payment? Well, you can do this using the formula below. That formula, by the way, is nothing more than an annuity, which we've talked about annuities earlier. Or you can solve this using your time value money buttons, which is much easier in my opinion. So n would be equal to 4, I would be equal to 8, present value would be equal to $5,000. The future value for paying off the loan would obviously be 0. You solve for payment and you would make a little bit over $1,500 a month in payments. Now looking at this problem in Excel, you would see that you could type it up in a similar fashion as what appears on this slide, and I've also given you the Excel link so that you can get in there and play around and even look at the formulas. But this is actually good practice, and a lot of you would maybe need to take a look at how this is set up. You're going to start with a beginning balance for each year, obviously $5,000 because that was what the loan was originally amounted, and you're going to end with 0 at the in year 4 at the ending balance. That's where that little dash is for, because now there's nothing left to pay. If you notice, you're going to figure out what your total payment is going to be, and then what portion that goes to interest and what portion goes to principal. If you notice, you're going to make the exact same payment each year, but a different amount is going to go to interest versus principal. You're going to pay more interest up front, and then you're going to be paying more principal in the later payments. Okay. Another thing is the ending balance for each year is going to be the beginning balance for the next year. Okay, so you just kind of work your way through this process till you pay off the loan, and that is, what amortization is all about. So this brings us to a really quick quiz on loans. What is a pure discount loan, which we've already just talked about? That doesn't really pay you any interest payments, but it's going to pay you everything off at the end. What's a good example of a pure discount loan? We've talked about the Treasury bill, but there's also zero coupon bonds. Zero coupon bonds are a really good example, because a zero coupon bond is, and we'll get more into this in bonds, like I said, but it's a situation where you could maybe buy a bond at a really deep discount, maybe because bonds are worth $1,000 each usually. You might buy it for like $300 and it won't make you any payments, but when it matures, you get the $1,000 back. So a lot of people use those in the past to help save money for maybe students going to college and things of that nature. But that's an example of a pure discount loan. What is an amortized loan? Obviously, we're talking about something that's going to have equal payments for a fixed period of time, and but that's going to pay more interest off in the beginning and more principal off towards the end. Eventually, it should go down to zero. A good example of this is obviously a mortgage on a house, right? So this should have given you a lot of information that you needed about time value money, and this concludes our lecture 2.3. If you have any questions, please let